In our sixth example, we're again trying to make a difference. We don't have a negative to factor out, which is nice. There isn't a common factor we can pull out of everything, especially you can see that easily, especially because that's just a 1x right there for our middle term. So let's get down to identifying the pairings of factors for the first term and the last term. So 1 times 6 makes 6, 2 times 3 makes 6, and that's it. To make 12, we've got options of 1 times 12, 2 times 6, and 3 times 4. This is one of those cases where, pardon me, this is one of those cases where we have a lot of products to consider that make a difference of 1. But I want you to see this. If you're trying to make a difference of 1, and you try 6 times 12, 6 times 12 is a big value. That's 72. 6 times 12 is 72. What's left is 1 times 1. You know it's not going to be the biggest one in this pairing of factors multiplied by the biggest factor of this pairing of factors if you're trying to make a difference of 1. If you're trying to make a difference of 1, you want the outer and inner products to be pretty close to one another. So the strategy would be to use the biggest factor in this pairing times the smallest factor in this pairing, and then the smallest one here times the biggest there. That's going to get them as close as possible. But it's not going to work with the 1 and the 6 and the 1 and the 12. Notice 6 and 12. 6 and 12 is not a difference of 1. So if we're trying the 1 and the 6 with the 2 and the 6, it doesn't make sense to take the 6 times the 6, because that's a very large number and a very small number. We want them to be very close in value. So if we try 6, it would make sense to multiply by 2. 6 times 2 is 12, 6 times 1 is 6. Difference is 6, it doesn't work. With the 6 and the 1 and the 3 and the 4, it would make more sense to try the 6 and the 3. 6 and the 3 makes 18, 1 and the 4 makes 4. That's not a difference of 1. If we do the 6 times 4, the difference is just going to be a greater difference. So clearly it's not 1 and 6. We've tried 1 and 6 with all of them. We haven't got an answer. That's okay. What will happen as you try these pairings for your outer and inner products, your mind will start to be able to see through the mess a little more quickly. And I'm sorry, it just happens from making mistakes that you'll be able to do this a little bit more quickly. So if we try the 2 and the 3, this is the larger number. We're not going to multiply by those larger numbers. We're going to try the larger number times the smaller number and see what happens. So 3 times 1 is 3, 2 times 12 is 24, 24 and 3, nope. So it's not that. Remember, we don't need to try 3 times 12. So now 2 and 3 and 2 and 6. It makes sense to do 3 times 2, the big times the small, and the small times the big. So that'll make a 12 and a 6. Nope. Again, it doesn't make sense to do 6 times 3 and 2 times 2. They're just going to get further apart. So it's not that. If it's not these, then this isn't factorable. Okay, so let's try again the bigger value times the smaller value. 3 times 3 makes 9, and the smaller value times the bigger value. 2 times 4 makes 8. What's the difference of 9 and 8? 1. So we're there. We just figured it out. Okay, so we're going to use these two pairings. Let's set up our binomial times our binomial. We'll have a 2x and a 3x. And the 2x gets multiplied by 4. The 2x gets multiplied by 4. The 3x gets multiplied by 3. The 3x by 3. There's our 9x and our 8x. And we want the difference to be positive. So that means we want the 9 to be positive, the 8 to be negative. You want the bigger one to be positive if the difference is to be positive. So for that to be positive, plus 3 right there. For the 8x to be negative, minus 4 right there. That's the factored form.